adding just a little more using our past knowledge, going back to our lab experiment where we had created thermal wind balance. We had also a subgeostrophic flow with the friction at the bottom, and we had our little Hadley cell happening here. Remember, with this visualization, you had created currents that are faster than the tank because it's going ahead of the tank, basically because you're moving momentum. You have created a thermal gradient and you've created the circulation, which means you are moving angular momentum from the edge to the interior, right? This is basically, think of this as the equator, this as the pole, cold, warm, angular momentum going from the equator towards the poles and creating westerlies. Westerlies means what? Again, repeat ourselves. Westerlies means winds are actually going faster than the earth. Boom. How do you do that? Basically by transporting angular momentum from the easterlies up into the atmosphere and poleward, right? So we had created the circulation near the surface that was in one direction, in the direction of rotation of the tank, going faster than the tank, so azimuthal velocities were faster than the tank. At the bottom we had created the subtropical gyre kind of flow where the subsidence is creating divergence, so you can see it's going in the other direction, right? So amazing that you can do that in the lab. And so we had basically created angular momentum transport. You also remember that when we increase the speed of the rotation speed of the tank, what happened, right? So this is what we were saying: pick up angular momentum and energy, transport it and over the subtropical gyres. We have seen this already. I'm just trying to repeat it so that you understand where we are headed. So let's think about moving energy in this kind of potential temperature structure with these Hadley cell circulations. What happens? So we've been saying already several times that the decrease in r, the distance from the axis of rotation with the latitude, is going to create angular momentum problems. We cannot have we don't have observed winds of 130 meters per second at 30 north, which means the system is breaking down into eddies. The system becomes unstable, just as we saw in the water tank experiment that we will see again in the next podcast. But we had seen this map, which was for something like January 21, 2003 or so. These were the temperature contours on the 500 millibar geopotential surface, right? So you can see the lows and the highs, and we said these when you saw in just the geopotential height, you saw highs and lows, which were basically the eddies, which we would call mesoscale eddies. How does it link to other things we have learned before? The size of those actually turns out to be controlled by the Rossby radius of deformation. You remember the Rossby radius of deformation has density gradient, gravity, and scale height of motion, and so on, the vertical scale of the motion. And it had F, so it depends on Coriolis or latitude. So Rossby radius of deformation decreases with latitude, so you end up with these eddies, which means the system breaks down. So the nice Hadley circulation that we are always showing breaks down at some point. Does it break down at the edge of the Hadley cell? Not quite. It will break down somewhere further poleward, and we will see how that works. Just to remind ourselves, the Hadley cell is well defined in the stream function, but as you go north, the zonal mean meridional cells are not so strong anymore, which means that the transport is happening with these wiggles and waggles of eddies. Okay, westerlies are not steady, but they are always wiggling, and they're creating these cyclones and anticyclones. So that's what we are looking at here, right? The warm temperature blob and a cold temperature blob, and so on. Right? The other thing we had to remember was that the temperature contours on a pressure surface was streamline of geostrophic shear, du dp and dv dp. Right? Height contours on pressure surfaces were streamlines of geostrophic flow, whereas temperature contours on pressure surfaces are streamlines of geostrophic shear. Okay, so just repeating, because you want to carry these concepts and be very comfortable with them and not get spooked every time we hear these things. Be very comfortable. Physics, physics, physics.